Hello everybody, welcome back. I'm going to be doing examples from section 3.3 and 3.4, the last two videos we have. Here's your homework assignment. I wrote it there. It's of course on Noodle. And so what I'm just going to do is, let's see, page 236, number 13 and number 15. So how about we do page 236, number 16. X squared 2x minus 3 squared. And it's asking for degree and leading coefficient. And so you have to imagine yourself multiplying this out. X squared times 2x, that's going to be a 4x squared right there, times another x squared, so the degree is going to be 4. 2 here and 2 here, degree. And then the leading coefficient, well, we're going to square 2x squared, that's going to be a 4x, times this, the leading coefficient will also be a 4. Okay, so that equals 4. And so that's that problem. Let's try number 14, because that's number 14 on the same page. Negative 2x squared minus 3x to the fifth. Negative 2x squared minus 3x to the fifth. I'm not sure what else goes on. Plus 3x minus 7 or something. The point is, what's the leading coefficient and what's the degree? Is 5. The highest, the greatest exponent is always the degree. So the degree is 5, and the leading coefficient is the one with the x to the 5, is negative 3. So those are those two problems. And then we'll try, let's go to here, the 37. It's just a graph, just a picture of a polynomial. Oh. Yeah. So I'm just making this up. There's a polynomial. Right now, by the way, I know it's even because I started down and ended down. I know it's even, and I know the leading coefficient is less than 0. But it has 1, 2, 3, 4, 5, 6. X-intercepts. There's 6 of them. There's 6 of them. So it's going to be a 6th degree, at least a 6th degree polynomial. The degree is at least 6. By the way, there's 5 bumps. 1, 2, 3, 4, 5 bumps. The degree is 6. At least 6, by the way. It could be 12. It could be not. At least 6. And there's 5 bumps. All right, that's that. Factored form. So what we're trying to do with all these things is find. The entire chapter is about trying to find these x-intercepts. Solve for x. Solve for x. That's why the last particular section we concentrated so much on the quadratic formula. That's solving for x. That's trying to find these. So that's what we do, and so this is like number, I'm doing number 26 on, I guess, that page, 230, just to see what, 2, 3n minus 1, 2n plus 1, negative 2, 3n minus 1, 2n plus 1, f of x equals, and it says determine the zeros. You know, what are the zeros of that? Well, that's never going to be 0, but that could be 0. And then that could be 0. And so solving them. And so those are the 2 of the points that hit the x-axis at 1/3 and negative 1/2. Solving for zeros of that. So let's skip to another factored form. Now I'm down here. I'm down in the second homework assignment, and it looks like I'm doing number. Well, you have 15, so I'm going to do number 13. Section 3, 4, page 254. Number 13. I don't know what it is quite yet. Whoops. Come on. 2 by 13. X cubed, x squared minus 20x. So here's a function, and it says determine the zeros. Zeros are the roots, determine the zeros. We'll call them zeros. Meaning, you know, where does it hit the x-axis? So in order to do that, factor. So much of this the strategies involved in this whole chapter is factor. Factor. Anyway, so I'm taking an x squared out. I'm taking an x out, rather. X squared plus x minus 20, and then I'm factoring that. X times x plus 5 minus 4. That's what f of x equals. So when x, the solutions are x equals 0, x equals negative 5, and x equals 4. How about another one to factor? Let's do a cubic. This is number 16 on the same page. Number 16. On page 254. Cube 2, 9, 18. Okay, that's what f of x is, and we want to set it equal to 0. Let me check the signs. Plus, minus. Yeah, good. So, you know, if factoring. I have to write this, by the way, exactly as is, otherwise you couldn't factor it. Always use your technology. If you have a calculator, just do it. So here we go. Looking at those two, I'm taking an x squared out of that. And I'm looking at these two, and I'm taking negative 9 out of that. And then here's a common factor. And so x is x squared minus 9, 0, x is plus or minus 3, and then x is negative 2. So there's the zeros of it using factoring. Okay, here's one from this section, an important concept. It's called the intermediate value theorem. VT, intermediate value theorem. And next semester, you're going to be talking about this quite a bit. But all it's saying, here is a picture of it. If you have a function going like that, and you have a point here, f at a is less than 0, and then you have a point here, f at b is greater than 0, that means there has to be a 0 in between. So all we're going to do, okay, intermediate value of x to the 5th minus 2x. In 1, 2. So I want to show that there's a 0 in between, in this interval. So f at 1 is 1 minus 2 is negative 1. Oops, is negative 1. And then f at 2 is 2 to the 5th is 32 minus 4 is 28. Because that's negative and that's positive, that's it. There has to be a 0 between. One more thing is multiplicity. Where are we? Okay, yeah. There's multiplicity of roots. For example, I guess we're down here somewhere. I'm doing number 32 on page 254. And we'll check it out. 32, Zeta, what's 32? X cubed, x minus 1 squared x plus 2. X cubed, x minus 1. This might not be squared. I'm not sure. Times 2x plus 1 or something. Come on, 32 times x plus 2. So there's a function of x. And so right now you know the zeros are 0, 1, negative 2. But hey, there's 3 of these. I mean, there's 3 of those because it's x cubed. So it's x times x times x. All 3 of those are zeros. So we call a 0 a multiplicity of 3. Of 3. Because there's 3 of them. We call 1 a multiplicity of 2. Now there are multiplicity of 2. And there are implications for that when graphing. Hey, the way we're in the modern world here, particularly now, use your calculator. I mean, there are implications of this being a 3, that being a 2, and multiplicity. But those are to be explored further. The examples from this time. See?